Let's start out this lesson by distinguishing the difference between expressions and equations. So an expression is a symbolic representation of a number or a quantity. It might look like this, 3x minus 2, or be a little simpler, x plus 3, or maybe n plus 3. Or even simpler still, it could just be a number. Expressions can be simplified. Equations, on the other hand, are expressions that have been set equal to one another. So a good example might be 3x minus 2 is equal to x plus 3, or n plus 3 is equal to 24. And unlike expressions, equations can actually be solved. So over here with the expression, the value of n or x can be anything, and that will determine the value of the expression. Well, over here, the value of n or x can really only take on a very limited number of values. So for example, let's say in this case, n is equal to 25. Well, you could substitute the n with the 25 to get the expression 25 plus 3, which is 28. Now that's different from over here, where n can't be 25. N has got to be some number that when you add 3 to it, you'll get 24. Which here, without doing any algebra, it's pretty easy to come up with 21. But solving 3x minus 2 equal to x plus 3 isn't going to be as easy. So we've got to look at some basic properties of algebra that we can use to simplify expressions and solve equations. The first property we want to look at is the associative property, which is the grouping property. And all this means is that if I have three different numbers, if a, b, and c are numbers, a plus b plus c is the same as a plus b plus c, which is also the same as a plus b plus c. So you can group terms together however you want across addition. And the same is true of multiplication. A times b times c is the same as a times b times c, which is also the same as a times b times c. So you can group terms together across addition and multiplication any way you want, and you won't change the value of your expression. That's the associative property, or the grouping property. So let's do a quick example here to see if we can get some understanding of what's meant by this. I'm going to let a be equal to 1, b equal to 2, and c equal to 3. And I'm just going to substitute those numbers in to each of these formulas. So a plus b plus c, that's 1 plus 2 plus 3. I'll bring my equal sign. Now this time I'm going to group the a and the b together. 1 plus 2 plus 3. And then this time I'm going to leave the a out by itself, or the 1 out by itself, and put the b and the c together. But it really shouldn't take much looking at this to see that this is true. 1 plus 2 is 3, plus 3 more is 6. 1 plus 2 is 3, plus 3 is 6. And even though 2 plus 3 is 5, plus 1 more makes 6. So this is always going to be true regardless of what numbers we choose for a, b, or c. Same is true of multiplication. Again, I'll substitute using 1, 2, and 3. So 1 times 2 is 2, times 3 is 6. 1 times 2 is 2, times 3 is 6. And then even if the 2 times 3 is grouped together, 2 times 3 is 6, times 1 is 6. The next property we need to look at is the commutative property, which is basically just the ordering property. The ordering property might be a little easier to deal with because there's no c, there's just two terms involved. And all it's saying is that a plus b is the same as b plus a. When you do addition, order doesn't matter. And the same is true of multiplication. A times b is the same as b times a. Order doesn't matter with multiplication. But we can do a quick example just to see. So let's just choose these numbers. Let a equal 4 and b equal 5. You could choose anything you want, but I'm just going to use these two because they're small and easy to illustrate the point. So I'll substitute in a plus b 4 plus 5 equals 9, and b plus a, 5 plus 4, still equals 9. For multiplication, 4 times 5 equals 20. A times b, 4 times 5, or if we change the order with a commutative property, b times a, 5 times 4, still equals 20. So the value doesn't change for multiplication or addition if we change the order. The third property that we need to discuss is the distributive property, which reads a times b plus c is the same as a times b plus a times c. Let's pick some numbers and do an example. So I chose these at random, and because they're single digits and they're easy to work with. So let a equal 5, so we'll substitute in the 5, parenthesis, b equals 2, plus c, which is 7. So 5 times 2 plus 7 is equal to, and I'm going to follow the pattern. The a and the b are now being multiplied together, and the a and the c are being multiplied together. So we're distributing the a evenly between the b and the c. And now let's simplify both the left side and the right side and see what we get. 2 plus 7 is 9, still inside parentheses, with the 5, and that's a multiplication, so 5 times 9 is 45. Let's see if we get the same thing over here. 5 times 2 is 10. 5 times 7 is 35. The addition sign comes straight down because we haven't used it yet. 10 plus 35 is 45. So these are the same. Here's an example of how we'll use the three properties of algebra to simplify expressions. Remember, this is an expression. There is no equal sign, but it's an expression that we can simplify using the three properties. So the first one I'm going to use is the associative property. Right now the 3x and the minus 8 are associated together, and I'm going to change that so that the 9x and the 3x are associated together, and the minus 8 is living out over here by itself. And now I'm going to do what's called combining like terms. These terms are considered alike because it's a constant times an x plus a constant times an x. So you can just do addition like you normally would and tack an x on the end. 9x plus 3x is 12x altogether. And the negative 8 comes straight down. So we took this expression that was written out in 1, 2, 3 separate terms, used our associative property to group like terms together, and then combined them and simplified. Let's do another example. In this example, I'm going to use the distributive property to simplify. Remember to follow this structure. A times b plus c is the same as a times b plus a times c. So we're going to distribute the term outside the parentheses across the terms that are inside the parentheses. So 9 times n plus 2 is the same as 9 times n plus 9 times 2. And see how the a and the 9 are in the same position, the n and the b are in the same position, the 2 and the c are in the same position. To further simplify, 9 times 2 is 18. So the given expression is 9n plus 18. In this example, I'm going to need to use a couple of my properties together. Let's start with the distribution. Note that the 3a, the 3 times a together are standing in for the b, and the 4 times c are standing in for the c. When I distribute across, I'll multiply the constants together and leave the variables alone. 2 times 3 is 6, but it was 3a, so 6a, plus 2 times 4 is 8, but it was 4c, so 8c, and I haven't done anything with the minus 3a yet, so I'm just going to bring that straight down. Now next, I'm going to use the commutative property to reorder. Anytime you reorder an equation, be sure you bring the sign with you. So I've taken the negative 3a and I've moved it over between the 6a and the 4c. 6 apples minus 3 apples is the same as 3 apples, because 6 minus 3 is 3. So 6a minus 3a is 3a. And then I'll bring the 8c straight down. And that's as simple as that expression can get. Algebra is all about structure. It's going to take a lot of time, a lot of experience, and a lot of practice to recognize how that structure works. Let's begin simplifying this expression with the distributive property. 3x is multiplying both the 4 and the negative 2n, so I'm going to distribute the 3x across the contents of the parentheses. 3 times 4 is 12. The x comes along for the ride. 3 times negative 2 is negative 6. The x comes along for the ride and meets up with the n. And the 3 times n times x we've done nothing with yet, so that just comes straight down. Do we have any like terms here? We do indeed. Think about the commutative property. A times b is the same as b times a, so x times n is the same as n times x. Thus we can rewrite the expression 12x minus 6xn plus 3xn. I've used the commutative property of multiplication on the n and the x. I've switched the order. Now it's clear that we have a couple of like terms, but be careful, we have a negative sign here. Negative 6 plus 3 is negative 3. So the x and the n come along for the ride. We did nothing with the 12x, so that comes straight down. In this example, it's easier to combine like terms first before using the distributive property. 2a plus 4a, or 2 apples plus 4 apples, is 6 apples. So let's simplify the contents of the parentheses first. 3 times 6a minus c. Now we're going to use the associative property of multiplication. Instead of grouping the 6 and the a together, we're going to move the parentheses to group the 3 and the 6. 3 times 6 times a, the minus c comes straight down. 3 times 6 is 18. The a comes along for the ride. The minus c comes straight down. There are no more like terms, so this is a simplified version of the top line. Each of these 4 is equivalent, but the 18a minus c is simpler than the 3 times 2a plus 4a minus c.